Okay, this one is asking you based on degree, how would you classify the function? And the degree is the highest degree or the highest number of exponent. In this case, the degree equals 3 because that's my highest exponent right there. This is a 2, this is a 1, and this is x raised to the 0th power. So the highest number again is right here is 3. Therefore, this function is a cubed. It's a cube function. That's how I classify it. And I graphed it out in decimal. If you don't have it, make sure you download it from in your iPhone. It's a wonderful graphing calculator that helps you understand graphs. Okay, and as you can tell, that this is a basically modeled after if I have a parent function of y equals x cubed. This is a variation. This red line is a variation of the blue line. I also want to do a quick review or introduction of even function and odd function. Really, all you need to remember is these two graphs. This leads to everywhere. The one at the bottom is a parabola, and that's y equals x squared. And the one to the right equals y equals x cubed, which is the cube function. And both of their leading coefficient is 1 because it's a parent function, and it's also positive. And that's why they are shaped the way they are. Now, this, when my degree of the polynomial is an odd number, I call this f of x an odd function. The f of x equals x cubed is an odd function. And by the same token, when the degree is an even number, I call f of x equals x squared an even function. Even function. That's just the definition of odd function and even function. Another thing I want to do a quick review is the power of, it's the effect of leading coefficient. Now, we've dealt with leading coefficient that's positive in parent functions. And in this case, the leading coefficient is negative. So when it's negative, it's a sad face. Positive, obviously, is a happy face, right? And if it's a cubed function, it switches over to the other side of y. And that's y equals negative x cubed. It makes sense, right? Because as x becomes bigger, say x go from 2 to 4, then y would go deeper on the negative side. So when x equals 2, y equals negative 8. When x equals 4, y would equal negative 64. So this side goes down, but on the left-hand side it goes up. Okay? So that's a quick review. And a new concept is and behavior, meaning meaning the and behavior of these functions right here, and how leading coefficient has an impact on them. So let's look at the blue first. If I have the blue, in the even function y equals x squared, as you can tell, when x approaches infinity, y approaches infinity, positive infinity. As x approaches negative infinity, y approaches positive infinity. But that's not the case in the even function. In the odd function. First of all, the behavior of the odd function is that when the function is odd, the and of the function splits. They are in different directions. Doesn't matter whether their leading coefficient is positive or negative. You have basically Indian dance hands, classical Indian dance hand. One hand is on one side and the other hand is going to the opposite side. Okay? So let's continue to look at this. Describe this function. First of all, you need to rewrite this function so that the highest power comes first, and then it goes on a descending order. So if I rewrite this function and rearrange the order, it will become something like this, right? At this point, let me see if I can find something lighter. I almost do not care what happens here. These are somewhat irrelevant so far. All I care about is all I care about is the highest power and the leading coefficient. Notice that my highest power is 11, so that makes my function an odd function. If I have an odd function, I must have Indian dance hands looking like that. Or it may look like the blue, right? We don't know. How do we know? We also know that my leading coefficient is 8, so that's positive. When it's positive, it follows this parent function. So I graphed it out on Desmos here, so you can see what that function looks like. As long as you conclude that it has the same behavior as the parent function y equals x cubed, you can draw the conclusion that as x approaches negative infinity, f of x also approaches negative infinity. And as x approaches positive infinity, f of x, the function, the y value of the function, also approaches positive infinity. That's the answer to that. Number 11 and 12, given the end behavior below, so now it goes backwards, state whether the degree of the polynomial is even or odd. Again, remember when we have even, the end behavior, the two ends are heading down to the same direction or heading up to the same direction. If we have odd functions, that's when the hands split. One goes up, the other one goes down. So in number 11, it says that if I have to draw this, if my x approaches y negative infinity this way, as my x approaches negative infinity, y is approaching negative infinity. So in other words, it could look something like this, right? As x goes negative, y goes more and more negative. And then the second condition says as x approaches positive infinity, y goes positive as well. So now all of a sudden I have an Indian dance hand and they're split into different directions. So I must have an odd degree. And because the way it's shaped, consistent with the parent function, my leading coefficient must be positive. Number 12, obviously they are heading towards the same direction. So without looking at anything else, I know the degree is an even degree. So this is an even function. And the leading coefficient, because this makes it a very sad face. Look at this. It makes a sad face. The leading coefficient is less than 1. Okay? Hope this is helpful. Talk to you soon.